back to problem number one really quickly and show that work. And all right, let's go to number three. So for problem number three, the description states three cables are attached to the top of the tower at A. Determine the angle formed by cables A, B, and AC if the height of the tower is 40 meters. So looking at this problem can seem kind of daunting because you might be wondering how you can find the angle between two vectors. But as you can see right here in our equations that we use, we're actually given an equation that is very useful for finding the angle between two vectors. And it's this cosine theta equals the A, the dot product of A times B over their magnitudes multiplied. And so we can use this information to find theta. All right, so I've written down some of the coordinates here, the origin, A, B, and C. What we want, or what we need, is the vector AB, the vector AC, and that is basically going to act as our A's and our B in this equation right here. So let me start this. All right, so let's start our analysis. So first, AB is going to be equal to, and then remember, final minus initial. That's going to be 16, negative 40, and 12 in meters. And our AC, following the same steps, using the same different points, but same point for A, is going to be equal to 16, negative 40, and negative 24. So 16, negative 40, and negative 24 meters. All right. So from this equation right here, this right here, AB is our A and AC is our B. So now we have basically all the variables we need. So let's just quickly get the magnitude of AB, which you can find by doing the square root and then squaring all the entries. So we have 16 squared plus 40 squared plus 12 squared, which is equal to 44.72 meters. And then you can do the same thing for AC, and you'll get that AC is equal to 49.3153 meters. And now let's plug into our equation. Remember that we want the angle, and this is cosine times theta, which is the angle. So at the end, you can either take or remember that we just have to take the inverse of cosine at the end of the problem. So we're going to solve for that and then take the inverse. So cosine of theta is equal to the dot product of these two vectors. So we'll have 16, negative 40, 12 dotted with 16, negative 40, and negative 24, all over the magnitudes. So 44.72 times 49.3153. It's important to note that these are all in meters at the end of everything, but as you can see, they will all cancel each other out. And so when we do the dot product, we multiply and add everything together, and then in the denominator, we can just multiply them together, and we'll get that it is equal to 0.711. And then After we do that, we can do that theta is equal to the inverse of cosine of 0.711, and that is equal to 44.6864 degrees. And that is the final answer for number 3. So yeah, nice little trick there using that equation, and shouldn't give you